Welcome to the group exhibit Hydrogen, Fuel Cells and Batteries at the Hanover Fair 2017. We are here at the Technical Forum and my name is Herbert Wancura. We have only 4 presentations left of this year Hanover Fair at the Technical Forum and I'm very much looking forward to the last 4 we have. Please join on these presentations, have a coffee, have some refreshments. I would also like to welcome our guests watching the presentations today online through our live streaming. The upcoming presentation will be regarding ready to roll out European projects with global aspirations. Please welcome with me on stage coordinator of the bulk H2 rail Alexander Schimanofsky and President of Synergesis Herbert Wancura.
Good afternoon, ladies and gentlemen. My name is Alexander Schimanofsky and I'm pleased to have the opportunity to present you the intermediate results of our bulk hydrogen on rail project together with my colleague Herbert Wancura. First, let me give you a brief introduction into our project. Well, if you look into hydrogen initiatives and the currently existing hydrogen transport and logistic chains, you will figure out that most of these logistic chains are based on the currently existing consumers and producers of hydrogen. So they are highly specified and mostly focusing on 2 modes of transportation, which are on the one side the pipelines and on the second side the transportation via truck on the roads. Well, regarding new developments, we expect that besides the existing consumers and producers of hydrogen, there will be new groups of consumers in the future. We consider 2 groups to be the most important ones. One group will be the railway sector itself, which we expect to be a major consumer of hydrogen in the future. And the second one, with even higher demand of hydrogen volumes, will be the industry, where you can find a strong tendency of greening of the industry, which will require new volumes of hydrogen, which are not needed for the time being. So for these 2 new groups, there will be new challenges regarding transportation, because distances are different, volumes are different, and we consider rail transportation to be appropriate means of transporting hydrogen to these new groups of consumers. Well, a few words about the study itself. We wanted to focus on the economic feasibility of new modes of transportations. And for that, we looked into several technologies. For sure, we consider the currently existing technologies like compressed gas hydrogen under different pressure, on different pressure levels, as well as liquid hydrogen. But we think that with those new scenarios coming up, other technologies also will have to be considered. For example, the metal hydrides, cryocompressed hydrogens or pressurized metal organic frameworks, and specifically the liquid organic hydrogen carriers, which seem to have quite some good potential for high volume transport of hydrogen. Regarding the logistic chain itself, we looked into 2 options. One is the monomodal option, purely on rail, and the second one is the multimodal option of combinations between road transport and rail transport and potentially other modes of transport as well, if useful. The project is performed by 5 partners with a duration of 12 months, and it's co-financed by the Austrian Research Promotion Agency, who enabled that project. The project partners, the first one bringing in the railway know-how and railway competence is RCC, Railway Competence and Certification, who is a notified body and whose major work is to do product and vehicle certifications for railway vehicles. The second
just as an input, Alexander heads that company, okay?
Yes. The second partner in the project covering the logistics and the organization of transports is the Rail Cargo Group, the cargo division of Austrian Federal Railways, with more than 100 million tons of freight a year, one of the major players in railway transportation in Europe. The second partner, and I also want to say thank you here for the opportunity to have this presentation, is the European Hydrogen Association, who also will take care of dissemination and who is a very important part regarding networking for all the members in the project team. The hydrogen competence is represented by Synergesis Consulting, which again is represented by Herbert Wancura. And the last company, the last partner of the project, is the Auto Cluster Styria, which is a mobility cluster and who is also supporting the dissemination and the networking side of the project. But now let me hand over to Herbert, and he will give you some technical information to the status of the project. Sorry.
Welcome. I'd like to go back to, of course, when you look at such a study, you need to decide what are we going to transport. Of course, hydrogen in different forms and levels of aggregation, but also how much. So currently in the German market, to use a starting point, we have roughly about 1,000 tons per day of hydrogen that are sold. Merchant market and hydrogen that's available as byproduct. Not all of the byproduct is sold. Then we think that that volume is going to grow. A, by natural means, and B, by the need of decarbonization of certain industries. They will need additional hydrogen because the existing hydrogen is already sold. Then we have this public transport development Alexander already mentioned. We expect that rail, after a slow start, but because of its lesser numbers of decision makers, traditionally the switch over of rail is relatively fast. The last power mode switchover of rail only took 16 years in Germany. So it took only 16 years to go from steam to diesel complete. Now, we will not see that this time, of course, but it's much faster than any of the other transport modes we see. And then we already have some starting significant bus activities. And then, of course, there's also the private car market, but there we admit being not quite as optimistic. So the relevance, if you look to the numbers, right now, you do not expect me to have any relevance on the private car market, a little bit on the bus fleet and public transport, and there's still quite a bit of an industrial market that we would expect. But as you can see, over time, for the next 15 plus years, we would see that the public transport will grow, mainly because we expect rail to grow. And of course, the rail will transport its own hydrogen, preferably on rail. That's kind of what you would expect them to do. The industrial volume was calculated to be the average modal share of freight transport in Germany, which is roughly 18% of total freight transported is transported per rail. The next element to decide, if you look at a techno-economic study, is what are the different technical solutions we're going to look at. At the moment, we are still having a few items open, but we're looking at the compressed gas in various pressures and different forms of geometry. We also have liquid hydrogen, as Alexander was already saying, and we were taking data of liquid organic hydrogen carriers in two formats. One in a 40-inch loading unit, so a container. That's mostly so we can compare it to the other similar solutions when we do an equal evaluation. But in reality, such a technology would most likely use a standard tank wagon, because that would be a much cheaper solution. You can also see that on the 40-foot container, you see the typical difference between liquid hydrogen, of course, delivering even twice the hydrogen content, even if you go to fairly high pressures of 50 megapascal. In 40-foot container, with certain limitations, the liquid organic hydrogen carrier is not as much better as the other. This one really plays out if you can take the whole tank wagon. There's a huge difference, of course, in the necessary capital expenditure for these units. And since at least the German liquid organic hydrogen carrier has been REACH certified, so not to be a dangerous substance, we have no RID, ADR type regulations to worry about, which would be the case for all the others. We're looking at that using some base scenarios of a business case. One is a major case, decarbonization of a steel plant. There is an EU project called H2 Future, where the iron ore reduction process, instead of being driven by coal, would be running with hydrogen. Of course, not completely at this point, because that would exceed all hydrogen productions we would have in Europe, or almost a complete one. So we're talking 1,200 tons per day. But what we are saying, let's try and think of 60 tons per day, one full train, and we ship it from somewhere where we have a lot of wind power, so that it's truly green. As technology option, we selected the tank wagon for liquid organic hydrogen carrier, although we are quite aware that that will take a bit of time before we can have this size of plant. So this is a point-to-point modal situation. We also were looking at a wind park in Austria East. And then the alternative is, assume a larger public transport node, one where you have buses, trains, etc., a classic refueling station that would handle both rail and street road applications. Daily need 1.5 to 2 tons. And let's assume you do that in a mixed transport, and you would do an intermodal relation, because you would not want to use the big capital investment. Now, I have to admit, the first case with liquid organic hydrogen carriers is of course the simpler one, because if we just look at the transport side, that's just a tank wagon circulation or rotation. Excuse me. You have the case where we have about a 200-kilometer distance, which is roughly twice what you would see today as a typical hydrogen transport distance. The cost per kilogram of hydrogen at the moment would be 43 cents. Now, if we would assume the large case coming from the Northern Sea, if we're Germans, let's say Flensburg or something like that, and bring it to this central Austria place, that's roughly 1,000 kilometers. The cost, of course, is higher, but it's only 87 cents per kilogram. So with 5 times the difference, we have only double the cost. And this is where the rail transport truly excels. If you need to think about hydrogen transport on longer distances and in larger amounts, for whatever reason, then that's when you need to start thinking putting these things on rail. Now, is there anything that could block us from doing that? This is where Alex gets back in, because he's an expert on all these rail regulations, codes, standards, and all these wonderful legal things.
Yes. Well, yes, for sure, there are some factors which could limit our chances on transporting hydrogen on rail. One could be the overall energy cost of the processes. This is something where we have to look deeper and into more details in the second phase of the project, for example, regarding the LOHC version of transport. And other things which could be, let me say, which could make difficult are the regulations, codes and standards which need to be obliged for the transport itself, for loading, unloading, or even for the equipment or the railway vehicles themselves. Based on these different groups of regulations, codes and standards, we started to do a small gap analysis to figure out if there are any open points which need to be taken care of in the future. Well, the first point, the transport of hydrogen on rail. Most of you are aware that hydrogen is considered to be a dangerous good for whatsoever reason ever. So fairly all aspects regarding transport of hydrogen on rail are covered by the RID. On road, they are covered by the ADR. Still, there are a few aspects which are not covered with that. For example, newer transport or storage technologies like the metal organic frameworks are not covered in the RID for the time being. And as Herbert already mentioned, the LOHCs are not to be regarded as dangerous goods for the time being. If there should be different or new liquid organic hydrogen carriers in the future, this will be something which will need to be considered. The loading and unloading infrastructure is something which is very important because the Directive 2012-18 puts a framework around mostly the maximum storable or allowable volumes and quantities of hydrogen to be stored, and all the boundary conditions which is regarding the capital expenses a very important point for the overall transport chain of hydrogen. Well, so this directive actually excludes the transport itself, including the, let me say, pauses of transport if a train is stopped in a station, etc. But it considers it covers the infrastructure. So all the infrastructure needs and requirements will have some influence or will have an influence on the economic situation of rail transport of hydrogen. For sure, there are other international and national guidelines and regulations as well. So there might be some demand for to make everything uniform, so that also for international transport and logistic chains, all those processes are standardized and everybody knows what to do and does the same. The codes and standard for the transport equipment are fairly set. For the loading units, they also are covered in the ADR or RID respectively. And for freight wagons, whichever you use, if it's intermodal transport, you have the container wagons. The same is valid for tank wagons. They are also common products. Only if you would produce or design freight wagons which include specific equipment for hydrogen handling, then you would have to see how this could be covered in the technical specifications of interoperability, which currently do not take care of those aspects. So the gap analysis actually brings out 4 major points. The first I mentioned already, it's new technologies which are not covered in the RID for the time being. The second one, the potential equipment installed on freight wagons will have to be handled a similar way as the installations on already existing but very new powered vehicles, like the hydrogen multiple units which are now introduced by Alstom. And international standardization of all those processes will support a very productive, quick and efficient transport of hydrogen on rail. There is one last point which is not very clear for the time being. If you have a disrupted transport, if you have a train which is transporting hydrogen and this train is kept in a shunting yard, for example, for, I don't know, 2 days, 3 days, is this part of the transport, or is this already storage of hydrogen? Depending on which direction the decision goes, it either is no problem because it is excluded from the relevant guidelines, or you will have to consider additional requirements there, which could be a disadvantage for rail transport of hydrogen. Well, so far this is the current status of our project. Thank you, Herbert. We are continuing our project until September and October this year. News to this project will be announced in certain media and with our network partners, but also on the 12th Hydrail Conference in Graz in June, 27th to 28th of June. And also on the Rail Contact in Graz, there will be the opportunity to learn more about this project. So, das braucht man nicht. Yeah. So
we have a legal obligation. Okay. We must say we're grateful. No, we are grateful. It's not just a legal obligation, of course. We're grateful that the Austrian Research Funding Agency has supported that project with the funds under the contract number 855 and 039. Thank you very much for listening. And if you have any questions, we'll be happy to answer them.
Thank you very much.
And we almost kept the time limit.
Herbert and
we did.
Alexander, thank you very much. Are there any questions from the audience? No? I was wondering, the project will be finished this year?
Yes.
Yes.
Do you have any vision or follow up where you want to go, or what you want to see afterwards, after this project finished?
Well, if the results turn out a way that it looks feasible to have hydrogen transport on rail, the next step will be to develop real scenarios with railway operators, and if there are significant gaps which need to be closed, we will take our role as a certification company to support and further develop those regulations which are not designed to a degree as it would be necessary for the future.
If I may add, I think what I hope to have happen is that people start to think about rail as a mode to transport hydrogen, because it could be a game changer. Technically, if you wish, it's somewhere in between the road transport and the pipeline. You can make a train, like we showed here, with 20 wagons. That's 60 tons of hydrogen transported in one shot. We don't have that unless you have a pipeline. And the cost is, of course, not exactly low, but it's lower than building a pipeline. Because once I have these loading units, that means I don't care for how far you need to go. Whereas in case of a pipeline, I can only go as far as that pipeline reaches, and that's the end of it. After that, I might be able to have a truck that adds another 100 kilometers. But if I have container boxes filled with these carriers, I can take them from the North Sea to Messina in Italy, and it doesn't make any difference. And I think that might change some of the debates that we also have. Is the only way to transport renewable energy via electrons that need to cross a lot of borders also?
Thank you very much. Do you already have railway companies, despite of course in Austria, that are interested in your project and want to further look into it after you finished your work?
We have some first debates. Let's put it this way. It's too early. They want to see more firmer numbers on more parameters than just the cost side. Also, that's the very critical one for them. Everything else comes kind of secondary, of course, but we need to have better data on energy efficiency, etc.
But basically, you can say, for sure, every railroad is interested to transport its own fuel. And that's
Great.
Also an important factor.
Thank you very much for your time, Herbert and Alexander.
Thank you.
If you want to have a closer look into the project they've just presented, please have a look at booth number C74. It's a European Hydrogen Association, and they will be pleased to inform you. We are a little bit behind of time. We will continue in about 2 minutes with the next presentation, one of the last three of this year's Hanover Fair. It will be highly accurate and lightweight pressure regulator in development for UAV drones automotive by Pressure Tech. Stay with us, have some more coffee or some refreshments, and see you in a minute. Thank you very much.